And now we're ready to move to a new topic, which I think is very interesting. Okay, we're still going to work with different variable types. Okay, and then trying to do all kinds of summaries that we can for different variable. So the topic name is group and pivot. Okay, we already talked about the group method a little bit earlier. If you remember, we're trying to summarize like the counts, okay, of a categorical variable. Okay. I think it was the top 200 movies in 2017, right? And then we're looking at the different studios, and then we were doing a tally count of those top 200 records, top 200 movies, how many are made by certain studio. And that's how we actually also introduced the bar graph, if you remember, like doing it as a decreasing order to show how different studios are doing. Okay, so we're going to revisit that to some degree. But then I also wanted to show you that the group method actually goes beyond the ones that we have seen. Okay, so we call this classifying by one attribute. Okay, and the method we're introducing again is called group, which we have seen before. Okay, so the group method, again, just to review, but then adding some new flavor to this. The group method aggregates all rows with the same value for a column into a single row in the resulting table. Okay, so imagine what we had done before about the movies and then the group method being applied to studio. Okay, so remember, studio is a categorical variable, right? And so what we're doing is that we're counting among all of the 200 top movies, how many are made by Studio One, how many are made by Studio Two, and things like that. Okay, so that's what we mean by is aggregating all rows with the same value, like Studio One, for a column, which is the studio column, into a single row in the resulting table. Okay, so that's just a final count. Okay, so the first argument, okay, is which column to group by. Okay, and that's actually what we have seen before, right? We use group just in the really the simplest way. We only have one argument. We're just like using the first argument. What we call over here is the name of the column to group by, which like in that example is the studio. Okay, but now we're adding some new flavor, like I said. Okay, we can actually provide additional argument. Okay, it's optional. That's why in the past we only provide one argument and it works fine. But we can also provide a second argument. It actually could be a function. Okay, it's a function name for how to combine those values. Okay, it sounds might be not as obvious as now, like what do you really want to do about the studio, right? Like you're really just doing the count. Okay, so that's a common reaction. Okay, so but I will show you now and then in the demo, like what are the possible arguments of the second arguments, which is the function that we can do. Okay, so the default is the number of grouped values. That's the count. Okay, so that's length, Len. It's default. So if you don't do anything about it, it's going to return you that. Okay. However, they can also give you array. Okay, an array of all grouped values. You can also do sum. Okay, total of all grouped values. Okay. So let me show you in a demo now. I think that helps much more than telling you what this are doing. Okay. So let me do the demo here. Okay. And for us, we're focusing on like doing group on one column at this point. Okay. So the data set, okay, is super small. If you remember the Cohn's data set, we have the flavor column and the price column. Okay. Flavor is a categorical variable. Okay. We have strawberry, chocolate, strawberry, well, just two flavors, I guess, strawberry and chocolate. Okay. And then we have price for each flavor over here for a particular type, I guess. Okay. So what we did before, if you remember, is we're doing the group method on the categorical variable, which going to returns us a new data table with the counts. Okay. So we know that we only have 5 rows in the original data set. So not surprisingly. Okay. And we are able to actually check if it is doing the thing that we thought it's doing. So we only have strawberry twice and then chocolate 3 times, right? So well, it is indeed what the 5-row table of the original is telling us. Okay. Now I'm trying to show you like the added flavor that I was talking about that you can do with the group method. Okay. So the first one, okay, is np.array. Okay. So what is doing exactly here? Is it doing anything about the flavor, or is it doing something about the other variable going on over here? That's something new. Okay, so let's look at the output. The output here is giving us actually the price array. Okay, so even though they put it in a bracket, but it's not really like an interval, it's just an array. So notice what it's doing here. We're saying that you're able to provide a new, like a second argument for this group method. Okay, and we're saying that is like the function being applied to that group. Okay, so what's interesting here is that if you don't do anything about the second column, then it's just really going to do the tally count for you about the categorical variable. Okay. However, in our particular example, you see that we also have this additional price variable, which is numerical. Okay. So if I am interested, okay, in, well, what's the price? What are the prices for strawberry flavor, right? What are the prices for chocolate flavor? If I want to report all of them, then I can use the second argument mp.array. Well, it's a function, now we know. It's really just listing, okay, listing the price of all of the chocolate flavors and then listing the price of all of the strawberry flavor. Okay, so this second argument, like I said, is a function, okay, but it's not only a function about the column that you're working with, but also about the additional column that you didn't actually explicitly call. Okay, so for us, the column that we're trying to group is by flavor. So that's all fine. Okay. However, we do have the price column that if we do a mp.array, it's going to list all of the prices according to each of the type of the flavors going on. Okay, so sometimes this could be handy. Okay. And like I said, the default is length. Okay. So if I do that, well, it will just be like the length of the price, which is the count. Okay. So that's why if you don't input anything, the default is giving you a count of each of the flavor. Okay. All right. What if I put min? What do you think the min gonna do? I'm gonna pause here for a sec. Okay. Yeah. So indeed, like everybody was saying, it's gonna give us the minimum, okay, of each group. Okay. So let's return that. Okay. So among all the chocolate, we know there's 3 over here, right? 1, 2, 3, and the smallest is indeed 475. Okay, same goes for the strawberry. Okay, so now you see that the group method, right, not only works for just like giving you the tally of counts. Okay, if you have additional numerical variable going on together with your categorical variable, for this case, ice creams, then you're able to do many kind of summaries, okay, about those about the additional numerical variable out there that could be really useful. Okay, so let's look at one more thing. What about this one? If I do flavor chocolate, okay, and then column, and then I do the min, okay, this is actually sort of like spelled it out for you what this group min is doing. Okay, so essentially what this new function, like not new function, like the new line going on here is that we're collecting, right, all of the flavor, which is chocolate. I'm collecting all of the prices and I'm taking them in. Okay, so this, not surprisingly, going to give us 475 because that's exactly what we have returned earlier. Okay, so you can think of this as a breakdown of what is doing behind the scene of that group method. But you can see that, well, the group is so much more efficient, right? You only need one line to do all of this, and you can do it for strawberry and chocolate. And whereas if you want to do it group by group, you will have to do all of the writing for yourself. Okay. All right. Lastly here, if I do an NP average, okay, I guess everybody probably will guess it right now. We're just taking the average of the price for each flavor and then report that. Okay. So again, this is a toy example, so maybe, well, I don't know if you care about the average price of a chocolate flavor ice cream and stuff like that, but what I'm saying is that we'll see soonish we're going to use the MB8 example again about the salary, and then there will be all kinds of group method that we're able to do over there, okay, depending on what kind of answer you wanted to look for. Okay, so let me do one more demo on the ice cream. So what if I want to know the range? What we mean by the range is that if I input an array, I want to know the difference between the maximum and the minimum. Okay, this is one way to measure how variable, right? How much variability of that variable is. Okay, so if I define that function, I can use this new function that I defined into the group method. Okay, just like the apply method that we did before, you can always create your new function and then doing it on your data table. Okay, so the price range that we have for the chocolate is only 50 cents. And then for strawberries like 3 times more. Okay, so of course there could be other functions you are interested in, so feel free to experiment. Now let me show you like on a bigger data set and how all kinds of like grouping can be done. Okay, so this is our NBA data set. If you remember, we have the player name, the position the player is playing, the team the player belongs to, and the salary in $1 million. Okay, so what we're doing, okay, a couple of things first. The first demo that I want to do is that, okay, what if I'm interested about the total salary of each team? Okay, of course, maybe you're thinking about, okay, if I want to do for like team Atlanta Hawks, I have to collect all of the Atlanta Hawks, right? Like I have to do the where, right? And then taking all of them and take the average. That's what's working behind the scene if we're going to use the group method. Okay, so the way to do that. So first of all, we're only going to work with the team column and the salary column, just because now you could probably have guessed, right? If you have more columns, if they're actually also continuous like category numerical variables, you probably are doing way more summaries that you want to do. So we're really only focused on salary column at this point. So we're only going to select the team column and the salary column, and we call it teams and money. Okay, and then we're going to do the dot group method. Okay, on the teams and money table. And remember, the first input is the column of the categorical variable that we want to do summary about. Okay, for us it's team, because I was saying that I wanted to know the sum of all of the salary of each team. Okay, so then the second input is the function, which is the sum, and we know that the sum is going to be applied to the salary, okay, because that's the numerical variable that is being summarized about. And then lastly, we're doing a descending order, so we're able to do a rank. Right, so Cavaliers is the top, okay, and then Oklahoma City Thunder, State Warriors, keep going. Okay, so that's one way you can use the group. Okay, so like I said, I posed the question early on. I was saying that, hey, how about we wanted to, what if we want to know the sum of the salary by each team? Then we can use the group in this way. Okay, the team is the categorical variable that we're doing the summary on, and then the salary is the column, the numerical variable that we're doing the summary of. Okay, so that's one example. Okay, and then of course, if you don't do that, what I was saying, that I just select the team and the salary, and then you will see that, well, there are other columns in the original data like player and position, because they're not numerical variables, so like no sum going to be reported for them. Okay, so you can do this, of course, it doesn't hurt, I guess. Yeah, same results after all. Okay, however, if you really just wanted to work on the team and the salary, then it's always a good practice on only selecting those two columns and do the group over there. Okay, all right, another thing, let's just say, okay, how about I want to do, now remember, there's also the position variable, okay, in the original data set. So maybe some people are more interested in, instead of about the team, I want to know, like, comparing to all of the different positions on the basketball team, I want to know the average salary, or the total, maybe average salary probably makes more sense. Okay, so if I want to do that, I'm going to select the position column, okay, and the salary column. I call it position and money. Okay, and then if I do only group on position, that's only going to give me counts. Okay, so we can do a count first, just to get a sense of whether, like, say, the number of positions are sort of like similar to each other. I guess maybe not so much. Okay, it looks like SG is the largest, and then center C is the smallest. Okay, so because of that, for any kind of summary, probably average works better than the sum, because you actually have different number of people in each group. When you do the sum, it doesn't really tell us much. Okay, so if we do np.average as the function, and then apply to the position categorical variable by doing dot group method, then what we're getting is the average salary. Okay, and then again, it's not ranking in particular, but we can always add the ranking over there. So you can now see the comparison across the average salary of different positions. Okay, so like I said, I think this is probably a little bit more realistic example if that's what you're interested in, compared to the ice cream example. But like I said, the group method, you can always do it if you really want by hard coding it, doing where and stuff like that, but it's not going to be as efficient as the group method. Okay. However, in order to use the group method most efficiently, we might want to do some kind of selection of the columns first. Okay, and then we have to think it through carefully about what exactly is the categorical variable that we're doing summarying about, and then what is the numerical variable that we're doing the summarizing of. Okay, I think that's the keys in working out the group method. So the more example and more exercise you do, I'm sure you will stick with you. Okay. Questions? Comments? Alrighty, if not, let me make sure today. All right, so now we know about classifying by one attribute, okay? But then we have seen that when we're doing the classifying on the categorical variable, we can do an additional summary, okay, about other variables if you want to, okay? So it's still, I guess, remain as a question of, well, if I want to do summaries or like classification about multiple columns, okay, what can I do? Okay, so the group method again proves to be helpful. So you can see that how powerful the group method could be. So we call this cross classification, okay, when we're doing this kind of summary across different multiple columns. Okay, we're still going to do the group method. We call it groups here just because it's about multiple columns now. Okay. And it's going to aggregate rows that share the combination of values in multiple columns. Okay, so first argument is the array for which the columns to group by. Okay, and the second one, just like before, it's going to be the function name. Okay, so let me show you without maybe staying on too much on that lecture slide. Okay, so we're going to go back again using the toy example because that's always easier to work with because we only have 5 rows if you remember. Okay. So that's the ice cream. Oh, never mind. I guess now we have 6. Okay, but never mind. It's a small data set. Okay, so we are able to verify what exactly we're doing. Okay, alrighty. So what we have seen before, if you remember, is doing a simple count, right? If I'm only doing the group method on a column, okay, a categorical column. And then of course, what we had done earlier as well is that what if I add one argument, like let's just do min, right? And then we're producing the price min, okay? So we're doing this summary, okay, of the numerical variable. So that's what we have seen so far with the group method, okay? Now, if you remember, like say here, we have the flavor and the color, okay? We'll have 2 categorical variables, okay? Maybe you want to do some kind of summaries across the 2 at the same time. So then that's where this groups, remember there is an S at the end, groups method could be useful, okay? That is helping us to make summary across 2 or even more categorical variables. Okay, so the way to use it is that the method is called groups. Okay, so you have to type dot groups. Okay, and then also in the input, you actually have to make an array of all of the column that you want to work with. Okay, so the way to do that, like what we're showing here, is you do make array, okay, flavor and color. So when we do that, okay, it's going to do, well, we didn't supply any other function about it, right? So naturally, it's going to give us a count tally. And what it does is that now instead of just the flavor, we're looking at each combination of the flavor and the color, and then we're giving a count. Okay. So if you have 2 or more categorical variables, this could be really useful because a lot of times your aggregation is not only about one categorical variable, right? It could be multiple. So for us, the flavor and the colors, for example, then we're getting the count over there. But also, just like the group method, the groups method can also allow you to give any kind of function that you want to apply. Okay, here is being used or like being called on, again, the numerical variable that you might be interested in. Okay, so for us, we still have the price. Okay, so any guess if after I run this line, what the output gonna be? We're using the groups method. We're doing flavor and color. And we are doing a max.
It's going to show the 2 rows that have 2 at the end.
What do you mean by 2 rows of the 2?
That's the max count of the cross listings.
Oh, okay. Yeah, so Juliana's point is that it's going to give us the maximum count of whatever this table that we're getting. Okay. Any thoughts? Agree, disagree, other ideas?
I was thinking it would give the max price for each combination.
Yeah. So Samantha also sending in the chat as well. Yeah, so I agree, especially I think the group method and the groups method actually work in a similar fashion. Okay, so whenever we're doing so Juliana, whenever we're doing a summary or like a function in the groups or group method, that function is being applied to a numerical column over here. Okay, so even though I agree, it's tempting to think about it's giving us the maximum count. Okay, and I'm pretty sure if you do max like in front of this, that probably will work, give you the maximum count. Okay, but if it's being applied into the groups method, it's giving us, I think, the maximum price of each particular combination. Okay, yeah. So for us here, as you can see from the title of, the name of the column is price max. Okay, and then it's also 4 rows because we only have 4 different combinations anyway. Okay, make sense? Sense? Yeah, so again, groups and groups, they work very similar. If you go back to our slides, it's two pretty much identical slides. We just changed the name of the function pretty much. So hopefully that also make the connection for you, okay? Alrighty, so let's bring it back to the NV8 example, hopefully a little bit more realistic, okay? So this is our data set, okay? Player, position, team, and salary, all right? So again, always try to drop the column that is not that useful. Like for us, like if we don't, like most likely we don't care much about the name of the player because we want to do summaries about position or team, right? Or position and team at the same time. Okay, so what I'm proposing here is that we're gonna drop the player column. So we do like dot drop, and 0 is, remember, the index of the first column. So we're dropping the first column, okay? And then we're doing the groups, okay? The groups here is we're doing team and position together, okay? And then we do np.average. So based on our lesson earlier about the max method, here, what this is doing is that it's gonna group based on team and position at the same time, okay? But then the average is gonna be reported for the salary. Okay, so what this function is doing, and let's see the output here. Okay, so see that the name of the player is being dropped. Okay, and then we're looking at all combinations of team and position. Okay, and then the average salary. Okay, so this is when I think groups is preferred than group because we're trying to do this kind of cross classification across multiple categorical variables. However, if you only want to know the average of by position, then we don't even care about the team anymore. We can even drop that and then only use the group method. Okay, so again, the changes so this goes back to the earlier demo that we did. Okay, so between group and groups, I think the key difference now we know, well, the name is slightly different, right? But also just the goal of what I want to do. If you only want to do summary about one categorical variable regarding like numerical variable out there, then you're going to do group. And then if you are doing more than one, like 2 or even more, you're going to do groups. Okay, but when you do groups, make sure that you have to pass all of the column names as an array. Okay, otherwise, I think it's going to get an error message of not recognizing anything. Okay, that's just the key usage over here. Okay, and let me show you one more example over here. This is a pretty large data set looking at age group, gender, education attainment, personal income, and population count based on like it's a tally in some sense about the different categories over here, different categorical variables, the age group, gender, educational attainment, and personal income in the US. Okay, so and in particular, we're looking at the data from 2014, sorry. Okay, all right, so one thing is that it depends on what you want to do. Okay, like what about, like, say I wanted to know let's just say like gender, education, attainment, and personal income. I want to look at like groups of all of those together, 3 variables. So this is an example of like grouping based on more than 2. Okay, and I want to know the total population count. Okay, so what this is doing is I will drop the age. Okay, and then I will be doing groups method. Okay, this time I'm doing 3 column, the gender, the educational attainment, and personal income all together. I'm doing the sum over all of the population count in order to get a total population count across all of them. Okay, so then this will give me my final table. Okay, so this is just an example of what if you have more than 2 categorical variables that you wanted to do this kind of summary with. In fact, you can do it with, I'm sure, with the age as well, because it's a categorical variable as well. For us, it's really just a demonstration of how you can deal with more than one, more than two categorical variables. Okay. All right, that's good. And let's get started on the last topic. And so then we can get more done. Okay, so let me share my screen one more time over here. We have the last topic in this topic 8 called pivot tables. Okay, so it's going to be, you will see that similar to some degree with the groups that we have been doing. But then again, depends on the goal. I think pivot table gives us some option about specific things that we want to do. Okay, so let me do the present mode. Okay. All right, so if we look at the definition, okay, pivot is trying to classify according to categorical variables. Okay, so notice here, earlier we are also talking about, okay, cross classification, like according to more than one categorical variable, right? We're using the groups method, okay? But one thing you probably notice, and soon when we do the demo, you will see that when we do the groups method, it's giving us the count, right, of all of the combinations of, like, say, two categorical variables, and it's returning us the count, which is non-zero, okay? But of course, sometimes you might have certain cross classification, like say a particular ice cream, I don't know, let's just say like strawberry and color is like, I don't know, dark, or yeah, you know, like that kind of combination might not be possible, which actually going to result in a 0 in the count, but like the groups method does not show you that. Okay, however, the pivot method is going to show you that if you want to return that as well. So this is actually a option over here, depending on what you want to do. So the pivot is going to produce a grid of counts or aggregated values, just like what we are seeing over here. But notice it's producing us a grid, okay? And we also call it contingency table, okay? We're going to have one variable on the rows, and then the other variables on the columns, okay? And then each of the cell of that table in the end is going to give us the count, okay? So you will need two arguments, both are required. Okay, the first one is the variable that forms the column labels of the grid. The second one is forms the row labels of the grid. We're going to do a demo, so you will see what I mean. And then you also have optional arguments, okay? Like say, if you want to do certain values about certain things, like additional column label that you want to do any kind of aggregation, or you want to do collect, okay? So it sounds a little bit vague, but I'm sure once we get to the demo, things will become a little bit clearer. Okay, so let me show you here. We're going to work with the MBA data set again, okay? And before we get there, let me just do one last demo about the group method, sort of what we have seen to some degree, okay? So for example, like the groups method, you're able to do multiple columns, like I said, okay? And then depending on what kind of function you're applying to, you might be able to do different things, okay? So for pivot table, okay, we're coming back to this ice cream data set, okay? So remember, if I'm doing, actually, I think, yeah, let me double check, yeah. Actually, I guess in Python, if you do groups or group, I guess if you are supplying more than one categorical variable, I think automatically they're gonna do groups anyway. So I guess in terms of like the syntax, no big difference, but it's a good practice to keep in mind that we do have like two different names for it, okay? All right, so here's what I mean. The flavor, when we do the groups, okay, do flavor and color, we're giving us it's giving us a tally count of the combinations, okay? But of course, it could be just like what I was saying, strawberry and light brown. Well, there's no ice cream like that, at least in the data set, okay? So the groups method does not give us the like a count 0 for that, okay? However, if we do pivot of flavor and color, it's gonna give us a grid of the counts where zeros are also there. Okay, so let me show you what I mean. Okay, when I do a pivot, okay, flavor, remember, is how the column's gonna be. Okay, and then the color, the second input, is how the row is gonna be, like what the row is gonna be. Okay, so dark brown, light brown, and pink, and then bubblegum, chocolate, and strawberry. Okay, if you look at this one, this grid, which is also, like I said, called contingency table, is giving us the exact breakdown of the count of each combination of the color and the flavor. And we do get some zeros here, like 0, like there's no dark brown and bubble gum, no light brown bubble gum, no dark brown or light brown for strawberry, right? And there is no pink for chocolate. Okay. So for this example, again, it's toy example, so maybe not as useful, but sometimes you do want to get this kind of contingency table over the groups because you might want to do that kind of summary more. Okay. So I think I will stop here just because I think we'll be running out of time if I keep going. But for us today, I think it's good to keep in mind that we did talk about group and groups, even though maybe the syntax probably wouldn't matter too much when you're doing in Python. And for us, we lastly introduced this pivot function, which is going to return us the entire grid instead of just the tally. Okay. And then, of course, just now in the slide, we're talking about their additional, right? Their additional argument that you're able to put in. So you can even do further summary about this kind of grid that we're doing about the other numerical variable, if you ever want to do any kind of summary over there. Okay, so just keep that in mind and feel free maybe to check out the demo even before we meet again on Thursday. But regardless, I think those will be useful tools that, I mean, not only for upcoming homework or lab, but also just thinking out loud in terms of the stuff that we're learning and then what kind of manipulation you can do with data. And then these are definitely useful tools. And then some of them really related to each other. Some of them may be a little bit confusing at the beginning or like maybe like hard to differentiate. But like I said, the more practice and exercise we do, I think things will become clearer. And then it does take time to get familiarized with everything. So just keep up the good work and reach out whenever you have questions.
Thank you.
No worries.
So what we're gonna do today, we got a lot of tabs kind of open. If you can see like my whole screen, I don't know. We probably won't get through all of them today, but we got like kind of like a lot of little topics. We're now getting things are getting interesting. Things are getting good. We're getting to the point where we've got some really good data analysis tools in our toolbox, and we'll talk about a couple more of them today. And then, you know, I think really kind of maybe this lecture and next lecture, that kind of wraps up all of the technology, kind of like all of the libraries and all of the kind of Python that we're going to need for the rest of the course. And so, so we'll do kind of a little, kind of the last kind of thing today and on Tuesday of the Python bits. And then it really gets to the point where we can really start doing kind of some serious data analysis, right? Kind of what we've been doing so far is we've been looking at data, we've been processing data, we've been doing computation. All the things that we've done so far are computation and visualization. And so we're going to kind of wrap up some more tools to help us out with that, just different ways of organizing data, right? And so organizing and visualizing data. And so once we've done that, then we can really start thinking about in the next kind of major concept, and we'll probably have time to get to it today, start talking about conditionals. So right now, what we've done is computation, right? We've organized data and we've done computation on data. Did things like we can group data together and we can perform computations on it. We can take the sum and the average. And we looked at apply. We looked at the ability of applying some function, some computation to a column of data, right? So really what we've done is we've done computation. We are using a computer, the compute, putting compute in computers. We've done computation. And really now, then the next step is that we're going to learn about conditionals. And now we're going to have the ability to make decisions. We're going to be able to decide. We're going to decide to either do this or something else based on input. And so that's kind of, one of the last missing pieces, this ability to make decisions. And we've been doing that actually, but it's been kind of buried inside of the library, right? So the where clause, so the where method on tables with the R clause, we've been making decisions, right? We've made a decision whether to include or exclude a row in our table. And now we're going to generalize that. We're going to generalize that with conditionals. And then kind of the next thing after that is we're going to introduce randomness. And then that's going to unlock, that's kind of our toolbox that's going to allow us to actually do the data science, the actual making inference, making predictions, and understanding the confidence, how strong our predictions are, how much confidence we have. So that's kind of the roadmap for the next couple of lectures. And so it's kind of exciting. A couple of announcements before we kind of dive right in. So homework 4 has been released. Homework 3 is due tonight at 11:59. Homework 4 has been released. We'll release Lab 5 this afternoon as well. And your first individual project, right? So that is going to be released this evening. And that project is in essence kind of think of it as a take-home quiz, take-home kind of take-home quiz that you'll have I think a week and a half to do it. And it's very similar. You'll see it's very similar to the homework, but it's a little more involved. This one, because it's in, the project is in lieu of a quiz. This one we ask that you do, on your own, no talking with friends, no talking with coaches, but of course you can definitely ask us questions like for clarifications if something doesn't make sense from there. And so we'll release that tonight. And you'll have a reasonable amount of time to do it. It's not meant to be that you should be working every moment on every moment of the day between now and when it's due. And it'll be due just before break. So we'll give you kind of the maximum amount of time to do that for there. And it's like a homework, but it's a little more involved. And so what we'll do, because you'll be working on on your individual project, we won't release a homework next week. Okay, so we'll have a homework this week, but after that we won't have another homework for the following week, so you can focus on the project. And I can definitely say some more on the project in lab tomorrow after we've released that. Okay, so I think those are kind of the announcements. So let's kind of pick up where we left off last time. So last time we started talking about, we talked about groups as a review, and then we introduced this concept of a pivot. And so let's just start off kind of with the demo. And so here we're just reading our MBA salaries table again. And then, right, this is kind of old news, like how to use the group. And so this is kind of a good review, right? And so what we're doing is we're taking our data, we're dropping the player. We're dropping the player column, and then we're going to do a group. We're going to do groups, okay? And so the new thing is we learned about group, which will group on a particular if we give the column name team, and that team is a categorical column. What group is going to do is it's going to gather all of the rows that match that are alike for a particular column, right? So, for example, if we're doing a group on this table with the team, it will collect all of the rows. It will collect all of the rows that have Atlanta Hawk, and then aggregate all of the data we want for a particular column, and then we can perform operations on them, or by default return a count. Right, so groups with the S, notice the S here, instead of just specifying one column, we're going to specify one or more columns inside of the array. And what it's going to do is it's just going to look instead of just looking at the team, it's going to look for all matching teams and positions, right? So team and position, if those two rows match both team and position, it's going to group them together. It's going to treat that as an entity. And it works just like the regular group, insofar as that then you can perform some operation, in this case, looking at the max for all of the remaining columns from there, right? And if we drop the player columns and we're grouping on team and position, the only thing left is the salary. So that will give us the max salary for all groups of teams and positions. So if we run that cell, we can see that we've now grouped, right? If we have multiple players, right? And so we do for the Atlanta Hawks, they have two C's, center. center. I don't basketball. So center. And they've now been combined. Right. And then what we did was, if you look at just these two centers, we've grouped them together because they're both the same team, Atlanta Hawks, and the same position. So those two will get grouped together. And then the function that we're applying on that group on the salary column is the max of these two data elements here. So 12 and 9.7, right? And so it took the max of that and gave us 12, right? If you actually wanted to see the values, you can do, instead of max, you can do NP array, and it will actually show you all of the particular values that got grouped together. And for our Atlanta Hawk C, we see it has the two values in there. It has the 12 and the 9 points, and there must have been yeah, the 12 and the 9.7 from there. And there must have been someone else in there, buried in the list somewhere, that had a $1 million salary from there. Okay. Go back to max. You see that? Okay, so that's group. And then, of course, once we have that, we can sort, right? This is the column that we're going to sort on. And then if we said descending true, instead of the default is ascending, and that will show the max going down. Okay, and so so here we're just grouping on the team, and this is going to give us the max. This is going to give us the the sum of the salary for each team from there. Okay, any questions about that? So really it's doing the heavy lifting of matching like-minded rows of the same category as specified in your column label. And then we can apply functions onto that aggregate data from there. Okay, and so it's worth remembering, it's worth pointing out the difference between group and apply. Okay, so group will collect all of the rows that match the one or more columns, and then the function that we apply, in this case sum, that is getting called on the array of data. It is getting called on the entire array. So physically what's happening is that array that was collected, that we saw up there when we changed it from max to NumPy array, that array is what's getting passed into the function, in this case max or sum. And so the operation that is the function that is operating, it is operating on the aggregate data, and it is performing some type of aggregate operation. The apply is very different. The apply gets applied, you specify a column, the apply function gets called once for every row with the input from that particular column. Do you see the difference there? It's getting called many times. It is getting applied individually to the data in each row separately. The group is a collection. Think of it as an aggregate. And the type of functions that apply that you would specify with the groups are going to take like an array. They're going to take a single array in as input, while the apply can just take any single value, and it will get applied to each and every individual row for that particular column. Okay, so that's the difference between apply, think individual elements, and group, thinking operations on an array. Okay, so now any questions before I move on to pivot tables? Okay, great. So pivot tables are really kind of fun. And it's a very easy way of helping us kind of look at our data. And so let's run through this example kind of quick. And hopefully I can kind of give some insights to where we get this name pivot table from. Okay, so we have this table. It has flavors, colors, and price. Here we're just doing a group, just like we did before. And so grouping will collect, right? So here we're collecting unique combinations of flavor and color. And so for every combination, so for example, here's one that has 1, right? So in our original table, we have 2 rows that match, that both are chocolate and dark brown. And we can just look up, we can see the 2 rows, the one right here and the one down there. And so that's why we get a count of 2. And the same thing for strawberry and pink. Here's our first strawberry pink, and then here's our second strawberry pink. Okay, so now pivot. Now what pivot does, and hopefully I'll give you some insights. And so that first column, flavor, again, it's a categorical column. And so what we're going to do is we're going to look at all of the values, all the categories in the flavor column. And for this example, we're going to have strawberry, chocolate, and bubble gum. It looks like, okay. And then let me stop sharing because I want to make sure you all see the visual here. And so the way I want you to think about it, right? The column, the categorical column has all of the categories in a particular column, okay? And what the pivot table is going to do, watch my hand, the pivot table is going to actually take those categories in the row, and it's going to pivot them. This is where it gets its name. It's actually going to rotate. So it's a vertical column. It's a vertical column of categories. The pivot operation is going to pivot on that column and turn all of those categories in a particular column into their own columns. And so if you think about that vertical column, we are now pivoting it to be their own columns. And that's where this name comes from. We are literally kind of taking that column and turning that column on its side. We are pivoting that column, okay? And the first column is the thing that we pivot on. Let me go back to screen sharing. Okay, and so we're going to pivot. And so now all the unique combinations, all the new categories in the flavor column will become their own columns. We will now have a bubblegum column. We will now have a chocolate column and a strawberry column. Okay, and then the second item, so the first column flavor is going to give us our new columns across the top of the table, and the color will fill in the categories for our rows. Okay, and then it's going to fill in that 2x2 grid. The flavor is going to be all of our new columns, and then the colors, all unique colors, will be their own rows. Okay, and by default, again, it's going to give a count. So let's just run that, and then we'll see what happens. Okay. All right. So now, as I said, you know, our flavors were bubblegum, chocolate, and strawberry, and each of those categories became their own column now. Now we have the bubblegum column, the chocolate column, and the strawberry column. And each unique color, and in this case, we have pink, light brown, dark brown, and we have those 3 colors. Each of those colors now became their own row in the table. So the first one controls the column. The second one controls the rows. And then it is actually going to do, by default, a count of all of those combinations. It's going to look at all of the bubblegum dark browns, all the bubblegum light browns, all the bubblegum pinks. And by default, it's going to give you that, the count. Okay? And we can go back and kind of verify this. And it will, if a particular category doesn't exist in our data, so dark brown bubblegum, that does not sound like a very appealing flavor and color. So it is not surprising that we don't have that unique combination. It will show all of those with there. Okay, and we can pivot on any column we want, right? So if we actually wanted a new table with all of the columns being now colors, we would just pivot on the color and then fill in the flavors from there. And then that will work as well. And so notice again, we're pivoting on the color. So all of our colors now become columns, dark brown, light brown, and pink. And then our colors now become our flavors. Yeah. Hello. Hi, do you have a question?
Yeah, I was wondering if we will always need to use group before we use pivot.
No. Absolutely not. This you can forget that this is even exists, because
Across from the original table, right?
that's right. That's right. That's right. So really, the reason why we put this demo in here, we really wanted to contrast kind of the group versus the pivot. And so thank you for asking that question. They are completely unrelated, right? We are working on the original all cones table from there. But it does give me a chance to kind of highlight the point that the group, what we're doing with the group is, think of it as really just being a particular instance. You know, we're picking a particular flavor to group on, in this case, flavor and color. The pivot will do that mapping for us. And so in essence, it is like a group, but it is doing kind of all possible groups and showing it as a table. So they're related, but they are definitely doing different things. And the similarities are in the sense that it's gathering, right? It is collecting categories. But in the case of the pivot, it is really kind of, it is doing almost like a cross product. It is actually getting all possible combinations of, in this case, flavors and colors, right? And so it's basically doing kind of a full-on group of bubblegums and you know, of flavors and colors and showing us them. So in that sense, that's how that group is similar into that case. But in this case, right, this is really kind of all combinations. And so in some sense, it's actually, if you're kind of in the exploratory phase of your data, a pivot table is really great to visualize. It's really great to see all kind of the combinations. And just like with the group, and we don't have to, it's not just the count. We can apply any function. And it works similarly to how the group does. So for all the unique combinations, right? For dark brown, well, here, let's pick one that has one. For all dark brown and chocolates, right? All of those combinations, we can now look at kind of a column, and it's going to group all of those. It's going to collect all of them together, and it's going to give us an array of all of the particular columns. And we can call a function on that, okay? And so here is kind of the full-blown version of a pivot table, with all of the arguments specified out. The column that you pivot on is always first. And then, so this is always going to be your columns. Those are going to be the categories for your columns. This will always be the category for the rows. And then here, this is also another column. This is the column to collect the data for everything that matches a particular color and flavor. Okay, so this is the column. That we're going to collect on. And if you remember back in that, this is simply the price of those particular items, okay? And then the last one is the function to call on the collected values, okay, for each unique combination from there. And it turns out that you can actually, here I've shown the actual parameters. You can actually just put price and function from there. You don't need the values equals and the collect from there. Okay, so let's see that example here. And so here, we're showing the max price for all of those combinations, right? And if you look kind of in the case of dark brown and chocolate in our original table, dark brown and chocolate, we see one is 525 and the other one is 525. Thank you. So max would, you know, but here, let's look at the other one. Pink. Here we go. Strawberry pink, right? We have strawberry pink. Sorry for scrolling very fast. Our strawberry pink, we have one for 355 and the other strawberry pink is 525. So the max should return for us 525, which it does. Okay, so that's kind of a toy example. Let's look at kind of how we can use the pivot on a bigger data set to kind of do some type of analysis for us. If you remember our MBA table, here's our salary. Here again, we're just grouping by team and position, but seeing the average. But what happens if we wanted to see all the positions, all of the teams, and and the average salary for all positions and all teams? okay? We can do that with one command with the pivot table here. And so when we pivot, it's going to give us, right? So the position is going to be our new columns. And so we have our center, all of those things. I think they're forwards and guards. Sorry if you're in the basketball and I'm not getting your team positions correct. And then the rows are going to be all of the team names, okay? And so what's really nice with that one command, we now have a summary of all of the average salaries for all of the players on the Atlanta Hawks who are with the centers, forwards, guards. Yeah, someone had a question.
So it's me again.
Hi.
So we don't have to worry about the categorical variables because it's not going to average that out, right? We can just write it like that for another instance, for example.
I think the answer is yes, but can you say that question again? I feel like I followed 80% of that.
Just when I'm doing an exercise and I want to do something similar, I can write the exact same way, considering that it is similar enough. And the NP average won't average out the categorical variable.
Oh, I got you. Yeah, so the average, this average is going to be applied to this gathered column, okay? If that makes sense.
Yeah.
And so the first two position and team, they're going to be categorical columns. The salary is often a numeric column, right? Because what's going to happen is that we're going to collect all of the unique teams and positions, right? And if you think about a team might have one or more centers, and so that array. And so we're going to look at all the unique combinations of positions and teams and collect all of their salaries together as an array, and then we're going to pass that into the average function, right? So this, whatever function you name here, has to be capable of handling arrays from there, okay? And so it's not going to do it on all of the other columns. It's only going to calculate this function, this average, on the values collected from this column, the salary column, which should be a numerical one if you're calling a numeric function on it, if that makes sense.
Perfect. Yeah, it does. Thank you.
Yeah.
The first
And it
one-
turns out, oh, sorry, I didn't mean to talk over you. Please go ahead.
No, I'm just clarifying that position and team are being pivoted, and then NP average is operating over salary.
Exactly. And it's operating over the collection of salaries of all of the matching teams and positions.
Sounds good. Thank you.
From there. And so now that we can do that, we can really do any type of analysis that we want. And so, for example, here, we're collecting the maximum salary for each position. And then at that point, once we have that table, so that's the table now that we have. So we have all of the particular, each row is going to be a team, and this is going to be a collection of their highest paid salary. And so presumably you can make the assumption that that these are going to be the salary of the starters, right? The highest, I mean, it's not a perfect correlation, but you got to think the highest paid salary is probably going to be your starter from there. And so that table gives us the salary of all of our starters for each position for each team. And then what we're doing down here is we're going to drop column 0, so we don't care about the team names anymore. And now we're going to take the sum of that, okay? And so what that's going to do is now here we're doing the apply. We're doing the apply, and the apply is going to work on each particular row one at a time from there. And so if we do that, what we're going to do is the apply is going to work on every column from there, and it's going to sum up the salaries for that. And so now we can get the total salaries for the sum of the salaries for all of the particular columns, right? So what we're doing here is we're adding back the total for that, right? So we're applying the the sum, and so that is giving us the total salary for each team from there. Okay, and then finally, once we have that, once we've added in the column, once we've added the column there, we can then now sort and see that the Cleveland Cavaliers is the team with the highest salary, and then there's the positions from there. Okay. All right. And so where the pivot tables really come into play is this allows us to compare different distributions. And so here, let's take a look at a different table here. And this table is a study of education and income, okay? And so we have a bunch of different types of, so we have a couple of category columns here. So we have age as a category, right? Even, you know, so we talked about this, that even though age can be represented as a number, well, here it's being represented as a category, right? We have these age groups, 18 to 64, and then we have 65 to 80, you know, we have all of these different categories, and the same for gender and education and income, okay? And you can see the incomes are coded, are A, B, C, D, based on different categories as well. And then we have the population, how many people are in that particular category, okay? And so the pivot will really allow us to kind of get a better sense of the data for comparison. And so in this case, again, we're going to pivot. And so just to kind of fit everything on a PowerPoint, instead of writing out all of the column labels, we're just using numbers here. And that is perfectly fine and can save you some typing at a little bit of cost of readability. But the important thing is if you go down that road, please remember that Python counts from 0. Okay, and so this is the age column is column 0, gender is the first column, and so educational attainment, that is going to be what we're going to pivot on. So all of the education are now going to become columns in our new table, and then our rows are going to be personal income. Okay. And then what we're doing is we're going to gather all of that data together. We're going to gather everyone, for example, you know, who had no high school diploma and salaries of 75,000 and over. And then we're going to calculate the sum of the population count. Okay, so that's going to give us the totals for all of that. And you can see how much easier now this is to reach, right? So really what we're doing is we're taking, because we're ignoring the age and gender, we're really grouping everyone together based solely on the educational and personal income. So in essence, what we're doing is we're grouping all of the males and females together, all of the ages together for that. And since we're taking the sum, that is now the total count for all of those groups from there, okay? And so again, we haven't done, we haven't created any, I mean, all the data is there. It's just how we're collecting it and displaying it from there. And so it's a very powerful construct from there, okay? So now that we have the data in this form, we can really kind of start doing some interesting things on it. So one, let's write a little helper function here, which is just going to give an array of count into percents, okay? And so if you pass in an array, it's going to turn each of those individual items in the array into a percent of the total of all the elements in that array, right? It's going to basically take the sum of that array and then divide each individual element by what is its contribution to the overall total for that array. Okay, so that's a little helper function. And so now we're going to use that. And so we're going to create a distribution table. So let's just run that first, and then we can see what's going on with that. Okay, so we're taking our income we're taking our education, our pivoted table, our edu income, and we're selecting column 0. Okay. And then we're adding the columns bachelor's or higher. So we're taking the first column of our table, and then we're going to create a new table, bachelor or higher, which is going to be the percent of the education column from the bachelor or higher category. Okay, so we're going to basically take all of those and calculate the percent for that column, and we're going to take the high school column and we're going to get the percentage off of that. Okay, so we see that is specified in the column 1 and the column 2 from there. Okay, so we grab the particular column and then just call percent on that from there. And you can see the kind of takeaway message from that is, if you look at the higher category, right, and this is telling us the percent of the population, that 35% of the population had a bachelor's or higher degree, and who were making $75,000 or over, or compared to only a little less than 10% who had a high school diploma. So that kind of confirms you should stay in school from there. Okay, and so we can take the sum of that, and that's just a sanity check, right? So we take our distribution table, and sometimes this is really good when you're kind of doing data analysis to take a step back, and this is kind of known as cross-checking. And so do the results give us what we think we're doing, right? And so we have all of these particular categories here, A, B, C, D, H, all the way through H. And then we have these percentages, right? And so as a sanity check, as we show all of these percentages, and these are all of the columns, right? These are all of the unique categories. And we know for a fact those are all the unique categories because we did a pivot. A pivot is going to make, it's going to show us all the rows and columns specified in the pivot. So we should have gotten all of the categories. And so if we show all of these percentages, if we sum all of our percentages in column 1, if we sum them, that should equal 100. It should equal 100. And we get pretty darn close, right? 99.99. So that is well kind of within the margin of acceptable accuracy for our calculations. Okay. And then if you wanted to look at that, this, now that we have this table here with these really nice percentages, now we can actually look at a bar chart, right? You can kind of get a sense of, yeah, it looks definitely the more income you make, the greater the percentages, but there's nothing, the classic saying, a picture is worth 1,000 words. And if you show the bar chart here, you can see the differences, right? So as income goes up, to higher salaries, you see definitely the percentage of people with a high school degree obtaining those salaries goes down. You can see through here, and the percentage of people with a bachelor's or higher goes up from there. Okay, so that's kind of a tour of pivot tables. It's a really nice way of grouping all possible combinations for categories in your data. Right? If you're kind of in the exploratory phase and you want to see how all of the categories for particular columns match up, use a pivot table from there. Okay. All right. I'm gonna stop this topic.